Hello, everybody, and welcome to today's session on Advent of Code in Kotlin. Early edition, I should say. We're starting a couple hours earlier than usual. So if you've managed to catch onto that part and decided that you would join us regardless of this slight shift in times, make sure you do say hello in the chat. I can already see a couple of well-known names out here in the chat, and I'm of course glad for everyone who decided to once again join us, or maybe join us for the first time. Maybe it's more convenient for your time zone. Who knows? The reason, of course, why we're starting a little earlier today, this we've talked about yesterday when we had Marton on the stream and we were doing things live from the Munich JetBrains office, is that we have a winter celebration happening later this afternoon, and I certainly want to also take part in that one because it's been quite the year. Loads of things have happened. But of course, before that, we have to solve our daily Advent of Code puzzles. There's no excuse there. So I'm curious if you've solved today's problem. Maybe let us know in the chat how you felt about it. Because I feel like this one might be slightly controversial with people. Who knows? In the meantime, I do want to once again give a brief call out to our blog post about Advent of Code in Kotlin. You've probably come across it already, but it's always good to give a little reminder that, of course, this being day 8 of our 12-day campaign, we are doing a bunch of other things in that also relate to Advent of Code in Kotlin. Not only do we have our Slack community that you are more than welcome to join, of course, we also have the leaderboards. And even if this is the first time you've managed to catch one of these streams, let me tell you, it is still possible for you to get something out of those leaderboards, because not only will people who are like top ranking will win something, also the people we will also just reward people who've just solved a couple of problems. So there is a chance for you to win something. Just join one of the leaderboards that still have free space. And of course, if you would like to continue the learning journey on your own, we have a bunch of resources, templates, and of course, important instructions on what exactly you need to fill out so that you can get the prizes. Right. Let's take a quick look here and see what people have had to say so far. Robert says, I'm still working on the second part, but I did just start 30 minutes ago. Well, maybe this can be like a live code along session for you then. Part 1 was okay. Part 2 was a bit tricky. That was not clear that the trick I used is legal. Very interesting. Maybe someone's exploiting some constraints in the input. Who knows? I still have sand in my ears from the sandstorm. That sounds very much relatable. Yeah. It seems that the general consensus is part 1, pretty straightforward. Part 2 took quite a bit of brain power. And also, apparently, the wording in the puzzle wasn't entirely clear, which also affected solving part 2. So we'll see how all of these things come into effect. But of course, like I actually mentioned yesterday, we are not alone again today. Like every day, we have a guest that brings a unique perspective on Advent of Code and on Kotlin. So I'm really, really excited to introduce today to the stream Salim, who is the team lead for Kotlin WebAssembly. Hey, Salim, welcome to the show.
Hi, everyone. Hi, Seb. Thank you for inviting me.
Yeah. So first of all, in case you haven't noticed it yet, dear viewers, I want to congratulate you, Salim, on a great release, because just yesterday, Kotlin for WebAssembly went alpha, which was a lot of work, but we're finally there.
Yeah, thank you. It was actually massive work of a lot of folks last year, especially last month. Thank you everyone who participated here, and please give it a try.
Yeah.
Also,
So,
I can show my T-shirt. Kotlin was a.
oh, wow, that's a wait. Can you stand up again for a second?
Oh yeah.
Oh, look at that. That's a great T-shirt. Even I don't have that T-shirt. That's very cool. Awesome. So yeah, in case you want to catch, of course, we'll see a bunch of Kotlin for WebAssembly today. That much I've been told, and I'm very excited about this. But of course, we do encourage you to start your own Kotlin for WebAssembly journey, maybe after the stream. So do stick around. But up until then, or when that time rolls around, I'd encourage you to maybe read the blog post. There's a lot of cool, not just a lot of cool information about what already works, all the new things that have been introduced, the fact that you can use WebAssembly in a lot of the major browsers out of the box without making any changes nowadays, and also, of course, the fact that Compose for WebAssembly is an experimental thing that you can already try out, which means that you can bring all your UI stuff and your UI knowledge that you might have from Compose multi-platform into the browser. And it comes with a bunch of other things as well. Performance benchmarks, next steps and what's in the works, and so on. So give that a read afterwards if you feel interested. I'm very excited actually to see how and in what form Kotlin for WebAssembly is going to become relevant for today's puzzle. But before we dive into this, I'm curious, Salim, do you have any background in like competitive programming, or have you done Advent of Code in the previous years?
Yeah, when I studied in university, I tried a bit of competitive, some contests. It's yeah, I like to solving puzzles, and kind of these tasks is kind of puzzles. Yeah. This year, honestly, I didn't participate to most of tasks. But last year I did some work. Yeah, I like these tasks.
That's awesome. Yeah, I mean, I feel like you were, again, I feel like you and a bunch of other people were pretty busy over the last couple of weeks here. So I feel like that's perfectly understandable. But it is great that you decided to join today, and hopefully show us how we might be able to solve Day 8 Haunted Wasteland. So without further ado, I think it's time for us to dive right into that problem statement, and then we'll see what you thought about it, what I thought about it, and I'm sure it's going to be an exciting journey. So, most important part first, the reading hat goes on. There we go. Got to make sure the little bauble is nice and present, and we are ready for Day 8, Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled Maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left or right instructions until you reach ZZZ. Or ZZZ, depending on, whatever pronunciation you prefer. This format defines each node of the network individually. For example, RL, and then we have AAA equals BBB CCC, BBB to DDD EEE, CCC to ZZZ GGG, and so on. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right by choosing the right element of AAA, which is CCC. Then L means to choose the left element of CCC, ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. RL really means RL, 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 and so on. For example, here's a situation that takes 6 steps to reach ZZZ. Starting at AAA, follow the left-right instructions. How many steps are required to reach ZZZ? Now, compared to yesterday's problem statement, this one's much shorter. I spent a good 10 minutes just reading out strange combinations yesterday. So this is nice and compact. So, Salim, when you read this problem statement, what were your initial thoughts?
Well, when I read first or maybe first 2 paragraphs, I first think about, okay, I need to implement some graph algorithm, maybe this one A star, maybe this time, maybe just DFS, BFS. But later, when I finish reading and after thinking a bit, I just come to, I think naive way should work here, and just go with naive way.
Okay. Yeah, I pretty much was kind of in the same boat, which is when the first part is so deceptively simple, I usually get very suspicious because I'm like, and what are they gonna do to us in the second part? And am I going to program myself into a corner? That's always the big question. Yeah, and we also have someone already pointing out that if you run out of left-right instructions, repeat the whole sequence of instructions as necessary. It's going to become crucial later on. So that's very interesting. Well, I guess we'll see about this. Very cool. Okay, so with that, we'll just switch over to your monitor, and you can walk us through the solution that you have. So I'm going to pull that up. If you are a fan of dark mode, then now it's the time to shield your eyes. So we'll switch over here, and here we go. Okay, all you, Salim.
Yeah. So it's my solution. It can look too complicated from first sight. It looks like so because I have a template from last year. So I just copy this template from one task to next task. It helped me a lot. I usually have in this template. I have some common stuff, but usually it looks like I start from this one when I super dummy reading. In most cases, reading shared between part 1 per part 2, and I just already have it extracted. Sometimes I need to do some common transformation at the end to give final answer, so it's extracted as well. After that, I have some helpers I use for these tests, for these tasks. Tests, it's not just a usual fun main. I prefer to use built-in support of test infrastructure inside IDE and Gradle itself. I use actually parameterized tests, so I load files from from my special input directory. It's very convenient from my point of view. When I need to run only one part, I just go to this test part one and run this test with shortcut. Here's one test what fails, but it's okay for because this test it doesn't create for first part. If I want to run second part as well, I can run only the second part, or I can run everything. It's I find it convenient.
That does actually seem quite convenient. I have to say I've not seen a lot of people do all of their work in the test source set, but that's a cool move.
Yeah. Okay. Back to the task. First part. Yeah. As usual, we start from reading. This time reading shred 100%. It's easy. We read all lines. First line is our instructions. We skip second line. After that, I drop first two lines. So other things is our mapping. So we go through this mapping and associate with from part before equals, and we have two direction parts, left and right, which was splitted easily. Firstly we split from destinations, and also split our destinations as well with comma. After that, we have pair of instructions and our mapping. And solution is super easy. We have variable for looking through instructions, and we need to count separately because instructions should be cycled. We have current, starting point, and target one, and just go through. We read current instructions, where we go with current one to left and right. You can see the structuring here. After that, we decide we go right on left. If left, we take L, or also R. If current is always equal to target, we just break. We increment our instructions variable. If it's more than length of our instructions, we drop it to 0, and that's it. That's easy. We get final number, and final number we just need to transform it to string. Easy.
Okay. Yeah. It does seem like a very straightforward implementation. If you could just briefly scroll back up to your associate function, I think that might actually be maybe the most interesting part here for people. So,
okay.
So it's just the if you're not familiar with the associate function, it allows you to turn a list of elements into a map of elements. And that's exactly what Salim does here. So in the very last line, you can see that he specifies a pair, and that's a pair of key values. So if you actually look at the type signature of map in line 15, you can see that at the end he gets a map of string to a pair of string, which is exactly the input. So it's the left three letters, and then it's the it is the like node's name, and then the left and right of that node, just in a way where you can look it up easily. Yeah, exactly. That's right. So exactly this kind of structure, and it just destructures very nicely.
Yeah, usually, yeah. Actually, I even have comment parts in the template, and usually when I have time and relaxed, I put here some important parts here, and I can just read everything here, and it saved in the history.
Yeah. Yeah, but apart from that, this is a perfectly valid solution, and I mean, there's no magic sauce in this. It just runs and does the thing that's required. But it probably would still be nice to get some kind of intuition to like what's actually happening and what this kind of would look like, right?
Yeah.
So if maybe you have something you want to show us.
Yeah. Yeah. We with Alexander from Compose multi-platform team. Actually, this visualization 99% was done by Alexander. And yeah, we did the visualization for first part. You can see magenta color is current place where we are, and green ones is possible places where we can go. By more bolder one is where we actually will go right now, and we can start simulation for simple. 1 second. Yeah, for simple task, it's too fast. Yeah, it's too easy. Let's try with biggest one. We have start point here. And
can you actually before you click it, do you know by heart where the ZZZ is on this grid by any chance?
Oh,
just so that people can look how far around we're jumping. But I guess we'll just see. Well, we can probably just run it twice.
Yeah. Yes.
Yeah, doing this on paper would probably take a minute or two. So thank God for computers.
Yeah, definitely. To make it visible, there is some delays. So I actually don't remember how much time it will take with current delay, but I think idea is understandable. It's look nice. I believe it will be super nicer with many cursors, but with limited time, we didn't manage to implement it. I think we need to do it and publish afterward online somewhere.
Oh, that would be quite interesting. Yeah. So yes, I've just looked up my puzzle answer again, and my puzzle answer is 17,873. So probably at the current execution speed, we'll sit here for a while.
Yeah. It's smooth.
Yeah. But that's perfectly okay. Do you want to try adjusting that speed, or should we just we can just also move on?
Yeah, let's move on.
Okay, sounds good. So we can briefly, before we continue with part 2, precisely because these are going to be very, very similar, I'll also just briefly show off my my code here. So let me just switch this over, and you'll see what is probably no real surprise here. So I did there's a couple of things I did ever so slightly differently, which is, let me just remove one line here, and then everything fits on the screen quite nicely. I decided, okay, I don't know what they're going to throw at me, so I will have some kind of data class that just encapsulates name, left, and right for myself. With just like Salim, I take the first line, and then I just use a regular expression for parsing. So here you can quite clearly see the pattern of first value on the left, and then on the right of the equal signs, you have two values that are within parentheses separated by a comma. Then I also use I also use a function of the associate family. For me specifically, it's the associate by function. That's just because I know that I want to be able to do quick lookups of nodes. So I'll have the node's name as the key, and then I'll store the entire object on the right side of my or as the value in my maps. And then it's as easy as grabbing ourselves a value from our start node. In my case, I use get value, which is pretty much equivalent to just saying nodes and then AAA with 2 exclamation points. Because if I wouldn't add those exclamation points that you also saw in Salim's code, it would be an optional or a nullable node, which is not what we want here. Later on, I go back on this approach. And then it's pretty much just it's a loop. I decided I would do the implementation of repeating the sequences a little bit differently, rather than keeping track of the place we're at right now. I'll just say we'll loop forever, and then within that loop we will go through all the instructions, and when we're done, this whole loop just finishes. We'll start again, like, from the start. But because I keep track of the current node and the steps outside of that loop, we of course keep that in our memory. And then it's just a matter of saying, okay, we'll update the current node based on the instruction with whatever node we have available. We make sure that we do count, and then we break out of this whole loop once we are done. But that's pretty much the entire, like, same approach. This is pretty straightforward, and it runs within a couple of or it runs rather quickly, and it gives you those 17,800 that was required for my solution. Great. Well, with that, we can move on and take a look at the...
one comment.
Yes.
Another way to deal with this instruction soup, I think we can take current instruction number as in your case is steps modular length of instructions.
Yes, I had thought about that as well. That's also a very valid approach. Or if you want to be fancy, you could also take these left-right instructions and turn them into a sequence, right? Which is a kind of it's a lazy collection. And I actually, without doing too much of a spoiler here, I do have an implementation for repeat infinite that does exactly that. So you can do this. I'm not sure if it's much clearer or not. I suppose that's a little bit in the eye of the beholder. Okay, well, with that, we can move on and take a look at part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. That part already scared the heck out of me. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. Gotta make sure.
Much better.
Gotta give the people what I need, what they need. A curious fact: the number of nodes with names ending in A is equal to the number ending in Z or Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously end up at nodes that end with Z. For example, this setup. Here, there are 2 starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, you use that instruction to simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node and you continue as normal. In this example, you will proceed as follows. See if I can get all of this on screen. I'll zoom out ever so slightly. Step 0, you're at 11A and 22A. Step 1, you choose all of the left paths leading you to 11B and 22B. Then you choose all of the right paths leading you to 11Z and 22C. You choose all of the left paths leading you to 11B and 22Z. You choose all of the right paths leading you to 11Z and 22B. You choose all of the left paths leading you to 11B and 22C. And then finally, you choose all of the right paths leading you to 11Z and 22Z. So, in this example, you end up entirely on nodes that end in Z after 6 steps. simultaneously start on every node that ends with A. How many steps does it take before you're only on nodes that end with Z? Interesting. So, of course, there is a little bit of a spoiler here on screen, but this one's a little harder to brute force. That one might take a minute if you just run the clear simulation. So, Salim, what was your thinking here?
Well, actually, every time when I probably switch to second part, I clearly see what just brute force will not work. Naive way will not work. But in many cases, I start from tuning naive way a bit. And this time I did it as well. I just fixed my naive way. Put the one loop inside infinity loop to go through all these cursors, all these states, current states, and it doesn't work in some foreseeable time. I just write it a bit and run and go to take my breakfast. After breakfast, of course, it didn't finish, so I I need to think more. I tried to tune naive solution. I try to pre-calculate something. It honestly takes some time to understand what I need to do, and at some point I just notice how actually the actual data, what I have, actual input looks like. I even cut some corners. Honestly, I started implementing a new solution with finding where I've met first time from A to Z, and I wanted to find next step when I met Z and find some cycle, and after that, after I found all cycles between for every parallel states, I need to do some math, but before writing all this thing, I just noticed what at least in my case, I guess in all cases for all users, it's true. When I first met Z, it was different step for each states, but there was common what it was last instruction, and after that I didn't see no more Z, so there is no repetitions. So anyway, as I see, they stopped in the same instruction already mean what I don't need to go further. After that, I had some 6 different numbers, and I just need to do some simple math. I can do LCM in this case, but again, I cut the corner and I just write a simple loop and it worked. So I stopped here.
Okay.
Probably I need to show my code.
Yeah, we'll take a look at your code here. But I also just figured that actually it might be a good idea. We've already seen a visualization of it, but just for the purposes of being thorough here, the overall like structure or size of the input, so that we have a bit of an idea of how many things we're traversing here, and then how this might also explode a little bit in complexity. So I'll bring your screen back up on the stream here, and we can take a look at what your approach was.
So reading is the same. So I just started step by step writing things. I found all start nodes. I print them all for myself to understand what's happening. Next step was finding next how much step I need to do to reach final node for each these states. So here is a big map things. So I take each state, each start node, and it's almost same as before. We have current one, current instruction, how much instruction steps we did, as well as before. We take current mapping, current step, and decide where we go, left and right. After that, we check if we finish or not. If we finish, we break, and we keep our C as the final result. Or we just, in some case, we need to go back and start instructions from the start. So here we don't see, originally I have like I to C here, so I just need to now instruction where I reach final state and final state itself, how much steps in total. So after I see everywhere I is the same, I just drop it. I worked it here for myself. It's how I realize it. So after that, it was simple. I need to find the number what could be divided by all these numbers I have. So I just go easy here. I found a minimal number and just go quickly with step by minimum brute force. Yeah, find next first number what could be divided by every other numbers I have, and as I find it, I just return it a string. I had another solution similar. You have in terms of using sequence. You mentioned sequences in previous part. I have sequence here. And I did the same things, infinity sequence. It's a bit slower, I think, but it's not so slow you can't wait it when it finish. I just make my loop solution. I first write simple loop solution. But after that, I just try to rewrite it with generate sequence. It's a bit slower, I think. Maybe
seems ever so slightly.
Yeah, that's it.
Well, that's a very elegant move, and I think you point out a very important point, which is you need to. With advent of code especially, you need to take a look at the structure of your input data.
If you have some competitive programming experience before, usually you trying to keep in mind all corner cases, trying to cover all these cases. It's usually not what you required to do with advent of code, but sometimes I forgot it as well as many folks.
Yeah, and I think Joffrey out here in the chat also mentioned this, which is the fact that a loop exists makes the solution possible, but the fact that the loop length is exactly the same as the position of the first end node is just a happy accident. Well, it sure seems like that is the approach, or that is what Eric intended people to do, or one of the approaches that was valid for the solution. Because if we, it's a quite a similar approach that I did here. We can take a quick look here. So the main part of this code is all the same. And you'll notice that, yeah, all I do is I try to figure out like how big are my like loops? How long does it, if I encounter a Z character, how long does it take me to encounter another Z character? But knowing whether this is correct or not isn't actually super intuitive. So what I did first before this was I actually just printed out like because you don't know whether it's always the same distance between things, right? You don't know if you have perfect loops or if there is some kind of like oscillation, right? Like if you're if because the phase between the number of instructions and the length of the loop, if those are different, then you end up in this thing where it's not just a circle, but it's like you might encounter the same node, but pick a different path. So you kind of end up in this slightly more crazy thing. So what I did, because I know that I only have 6 paths I need to check, is for each of the paths, I literally like looked at it, and I looked at the first couple of results of like how long it's been since the last Z value. Because I wanted to see if there was any in here where the value flipped between 2 different values. So if one of the paths was longer or the other path was shorter, or there was another like shift in period, I would have to do something more difficult. But for the input that Advent of Code provides, it seems to be that these are always exactly the right length. So now you can really think of them as just like circular like cycles that you go through. And at that point, if you're like not super familiar with the math behind this, you can kind of think of it as like planetary orbits with like different like times, like how long they take to orbit. And then the question is how can you express like the point where all of the planets like coincide, where they're all in the same line. And you can actually Google this, and I think the Wikipedia article for the lowest common multiple actually has a paragraph which is like correlation to planetary periods or something like this. So you might end up there if you like go with this metaphor. And then once you have that, what you can of course do is you can figure out how in your language of choice you calculate the lowest common multiple. In my case, the LCM implementation uses the Wikipedia definition, which is you'll take the you essentially just reduce over the accumulator multiplied by whatever your integer is, and you divide it by the greatest common divisor, and that's something that Big Integer has for you from the Java standard library. However, I'll also let you in on another trick. Once you have these printed out, you can just open a web browser and go to a website like Wolfram Alpha and ask for like lowest common multiple of these numbers, and that is going to just give you that. So if you know the function that you need to use, you can like just skip ahead to that part, which is a great way of like not getting lost in the weeds of the implementation.
Have you tried to ask AI assistants about that?
I have not, because asking AI is, well, I personally don't use any AI support in during my Advent of Code challenges. I feel like using what is essentially a scientific calculator is okay, in my opinion. That's where I personally draw the line.
Okay.
Yeah, but yeah, Alexander also mentions here that in the input values, you happen to encounter Z without a pre-period, so that is exactly at times divisible by some number, which makes it easier by another order. And that's exactly like the thing that we're either implicitly or explicitly exploiting with our implementation here. Yeah, exactly. It's the part where it's like the loop length is exactly the same as the position of the first end node. And yeah, look at that. Big integer has GCD implemented. I'm glad I was able to share something new here. I also actually didn't know this up until this morning.
I
But
did know.
after some poking around, now the question is why does it not have LCM just supported out of the box? I guess that's but it's a nice extension function, I suppose, that one could easily write if one were to take this and just press the button to say convert parameter to receiver, and then that's already an extension. So that's nice. Nice and easy. Yeah. Awesome. Great. And with that, this is kind of the puzzle. I have to say, so first of all, a couple of things here came true. First of all, I asked Martin yesterday what he predicted was going to come in the next couple of days, and he said graphs. Like he said, where are the graphs? Where's graph traversal or whatever? And well, lo and behold, here we have one. So we managed to get that part covered. I guess we'll see what comes next. So far, I still don't think there has been a problem that requires you to apply recursion in any meaningful way. So that might still happen. We'll see how it goes. But I'm also quite surprised that doing least common multiple or like remainder-based logic stuff came this early in Advent of Code. I think that is typical, or from my experience, I always had the feeling that this was usually reserved for slightly later days. This time, you definitely had to do this. Wonderful. Great. So, Salim.
Yeah.
I think we could still go a little bit further with this though. So I'll bring over your screen again.
I want to show a bit something else. One more thing. Yeah, I just quickly tried to measure performance of my solution with different backends, specifically with JVM and WebAssembly backends. And I was surprised 2 times. Let's look if I can repeat it. So I just here's part 1, and I do some small warm up and measure time, how much time it take with both targets. So let's try to run it. It is JVM1, and I run it with T8. Yeah, let's take a look. Okay, so we get some numbers. Here's JVM1. Oh, this time it's much higher. Before it's 5 seconds, and in case of WebAssembly, it's about 2 seconds. I was surprised, very surprised about this number. Usually with I should say with number crunching tests why I run before JVM be a bit faster, or WebAssembly is very close to JVM, specifically with number crunching. WebAssembly already very good with number crunching. Next time I was surprised with second part, but different way. Let's look. This time JVM 1000 second. No, I think it's milliseconds. Yeah, and we need to wait. Yeah, it should be milliseconds. Yeah, this time WebAssembly is much slower. I think 20 times slower when I tried actually.
Do you have a guess as to why that might be?
I'm not fully sure. Maybe we have string manipulation, maybe collections. We need to. I didn't have much time to look inside to look on performance snapshots. Maybe it's something related to strings, maybe with collections. I need to check later. If we have result, yeah, it's about 20, maybe less than 20 times slower.
So
Yeah.
just
One.
for yeah, so just for context, you were using you said you were running this in D8, and I'm not sure if people know what D8 is.
Oh yeah, sorry, sorry. It's a special version of V8, like debug V8. It's just standalone version of V8. V8 it is a virtual machine used inside Chromium browsers. V8 run. It's nowadays it's virtual machine for JavaScript and WebAssembly, both. In mostly for testing reason, we use standalone D8s and for benchmarking things. Yeah.
And so is V8 also the same engine that powers Node.js? Is that correct?
Yes, exactly.
Okay. And so now that so Kotlin for WebAssembly builds on the garbage collector proposal, right? And that has been like moving along quite nicely. So is there something like special that people need to enable to run it in D8, or does it just work now?
No, it's about, I think about a month, maybe a bit more ago, it was turned on by default. So it in case of V8 and JavaScript, Spider Monkey in Firefox, it turned on by default in standalone versions inside browsers as well. So just works out of the box.
Okay, very cool.
Yeah.
And I mean that's not just like, obviously you can run that stuff for business logic, but as we've seen earlier, you can also use Compose multi-platform for web, which uses the WebAssembly backend to allow you to build cool visualizations or just actual applications, depending on whether it's Advent of Code time or not. Yeah, very nice. So if you want to continue your Advent of Code journey, you already know where to go. But if you do want to continue your WebAssembly journey, I'm going to post the link again once more, because I think it would be quite a delightful new thing to look into. After all, Kotlin, Advent of Code in Kotlin is a great time to try something new. Whether that's notebooks, or trying Fleet, or trying Amper, or trying Kotlin for WebAssembly, or trying Compose multi-platform, there's like a billion different ways that you can tweak and tune these wonderful December puzzles into something that will also be a very beneficial learning experience for yourself. What's somewhat important here is also that we try to make it as easy as possible to get started with Kotlin for WebAssembly. We do have a community on the Kotlin Lang Slack, so make sure you pop on over there and maybe say hi. If you're already in the Advent of Code channel, here's another channel that you can join, the WebAssembly channel, and hopefully you'll find some other like-minded people who are quite as excited about the technology. There is also a webinar coming up. So if you are interested in having a live session, once again, with our very own Zalim over here, I'll also post a link to that one. You can sign up here, or you can just set a reminder on the Kotlin YouTube channel. So if you just go over here and you go on the live tab, you'll find that one right here. Kotlin and WebAssembly unleashing cross-platform power. So make sure you take a look there as well. Wonderful. And here's another point that I was asked to shout out. If you do want to meet me or Zalim or anybody else in person, there is still an opportunity to actually do this, because KotlinConf 2024 is coming up in May, and right now there are still some tickets left over. So if you're quick, you might be able to jump on that, and you might be able to say hi to us, ask your questions, and I don't know, if you bring your laptop, you can brag with your leaderboard placement higher than any of us or something like that. That's all your choice, of course. Wonderful. Cool. I think that's it, Salim, right? Do we have anything else?
I think that's it, yeah. Thank you, everyone. Thank you, Seb, again. Please join our WebAssembly channel in Slack. If you have any question about Kotlin, WebAssembly in general, or Kotlin WASM in combination, feel free to ask questions or just to discuss things with the community. As well, you can find me in social media by my last name and ask me there. Feel free.
Wonderful. Great. And of course, we do hope that you will tune in again in the coming days, because we will continue these live streams all the way to the 12th of December. The upcoming streams are going to once again feature a couple of interesting guests, so make sure you don't miss those. We've already seen a little bit of visualization today, and I feel like maybe in the coming days we'll see some more nice and beautified Advent of Code puzzles. Those streams are going to happen at the regularly scheduled hours again. So those are going to be a couple of hours later compared to when we started this stream. The reason for that, once again, being that there is a Christmas party waiting for me. So if you'll excuse me, the Christmas hat is going to see some more use today. And I think I'll have to get ready if I can make it through this this snow that's out there in time for the first round of Glühwein. So yeah, thank you again so much, Salim, for coming on, and thanks everyone who tuned in. So I hope that you have a lovely evening, afternoon, or day, and I hope to see you again tomorrow. Take care, everybody. Bye-bye.
Bye-bye.